Oxides are binary compounds of oxygen plus any other element. So, oxide is only made up of two elements, of which oxygen is common, and it is existing in combination with either a metal or a non-metal. So, these compounds are known as oxides. Some common examples of oxides include carbon dioxide, nitrogen dioxide, zinc oxide, calcium oxide, sodium oxide, and so on. So, all these are examples of oxides, and as you can see, oxygen is common in all these examples and it is existing with another element. Now, oxides can be broadly categorized into two categories. Oxides can be classified into major categories. We have the metal oxides and the non-metal oxides. So, as the name itself indicates, metal oxides are a combination of metal with oxygen, and non-metal oxides are combinations of oxygen with a non-metal. Metal oxides are again in two different categories. So, metal oxides can be basic oxides or amphoteric oxides. Metal oxides are again subdivided in two classes, basic and amphoteric. Similarly, non-metal oxides are also classified into subclasses. So they can be acidic oxides or neutral oxides. So this is the basic classification of oxides, metals and non-metal oxides, and each of them is again divided in two different classes. So let's study about the metal oxides first. Let's study about basic oxides. And basic oxides are coming under metal oxides. Okay. So again, as the name itself indicates, an oxide that gives a base when dissolved in a water molecule is known as a basic oxide. So basic oxides or oxides that give us a base when they dissolve in water. Now some best examples of basic oxides include sodium oxide and calcium oxide. Sodium oxide and calcium oxide are two very good examples of basic oxides. Now, as per the definition, if you see, sodium oxide combines with water to give rise to sodium hydroxide. Sodium hydroxide is a base. So, sodium oxide is considered a basic oxide because it will produce a base upon reacting with water. So, we can also take calcium oxide and upon dissolving in water will form calcium hydroxide, which is also a base. So, basic oxides dissolve in water and form a base. Now, let us look at some basic properties of basic oxides or metal oxides. So, most of these oxides are solids at room temperature. So, metal oxides are usually existing as solids in their physical state, and they have very low solubility in water. So, most of them have very low solubility in water. And as we have seen, they usually form alkaline solutions. They usually form alkaline solutions. So, as we know, an alkali is a water soluble base. So, sodium hydroxide and calcium hydroxide will form an alkaline solution, and the pH would be usually greater than 7 as it is a base. Another important property of basic oxides is their reaction with acids. Now again, if we take an example of copper oxide is a basic oxide, meaning it's a base. It can combine with acids like hydrochloric acid. And as we all know, the reaction between a base and an acid would give us a salt and water. So in this case, we have copper chloride plus water. So copper chloride. So as we know, the valency of chlorine is -1. So copper would exist in +2 state, and that is what is shown here. Okay. So basic oxides usually combine with acids to form salts and water. And this is also an example of a neutralization reaction. Next, let us look at amphoteric oxides. So amphoteric and basic oxides are both included under metal oxides. So some of the metal oxides that exist in nature are actually amphoteric. So by amphoteric we mean they are oxides that can chemically react either as an acid or as a base. In contrast, we had the basic oxides that can only react with acids. Now the examples that we study here can act both as an acid as well as a base. Two best examples for amphoteric oxides include zinc oxide and aluminium oxide. Okay, again, zinc and aluminium are both metals, so amphoteric oxides are just a subclass of metal oxides. Now let's study their amphoteric nature. First one is their reaction with acids. Reaction with acids, meaning the oxide is actually acting as a base. It is acting as a base. So first one, zinc oxide combines with acid to form the salt, which is zinc chloride plus water. So the reaction is already balanced. So we have the salt, which is zinc chloride. So in this example, zinc oxide is acting as a base because it can combine with an acid to form salt and water. So let's study the reaction with aluminium oxide. So Al2O3, it's a base. It's acting as a base. It can combine with HCl. It forms aluminium chloride, which is AlCl3 plus 3 molecules of water. So aluminium chloride is a salt and HCl is the acid. Again, this is a neutralization reaction because it forms a salt and water. Okay. So here we have seen the basic property of these two oxides, which is zinc oxide and aluminium oxide. Now let us look at the other reaction, which is their reaction with bases. So meaning the oxide is now acting as an acid. It is acting as an acid. So the first reaction again is zinc oxide plus a base, which is sodium hydroxide, and it forms sodium zincate. Sodium zincate plus water. So to balance the reaction, yeah, so this is sodium zincate. So here zinc oxide is acting as an acid and it can combine with a base to give rise to sodium zincate and water. In the last example, we have studied zinc oxide as a base. Now here it's an acid. Similarly, we can also write the reaction for aluminium oxide plus sodium hydroxide gives rise to sodium aluminate. Sodium aluminate plus water. So to balance the equation, so we have two sodiums here, so it becomes 2. And 5 oxygens on either side. So this is sodium aluminate. Again, here aluminum oxide is acting as an acid. It combines with the base, which is sodium hydroxide. So these are the reactions for amphoteric oxides with both acids as well as bases. So the two best examples for amphoteric oxides include zinc oxide and aluminium oxide. So to summarize, so we studied metal oxides, M as in metal oxide. So metal oxides can be basic or amphoteric. So an easier way to remember this is like MbA. So metal oxides in nature can be basic or amphoteric. And next we'll be discussing about non-metal oxides. Non-metal oxides can either be acidic or neutral. Let's study them in the next slides. Non-metal oxides can be acidic or neutral. So we can remember them as non. So N as in non-metal oxide can be an acidic or neutral oxide. Now let us discuss about non-metal oxides. Non-metal oxides include acidic oxides and neutral oxides. So these are the two subclasses under non-metal oxides. So let's study about acidic oxides. Acidic oxides. And as it's there in the name itself, an oxide that when combines with water gives rise to an acid are known as acidic oxides. So oxides that dissolve in water to give rise to an acid are known as acidic oxides. Some common examples include carbon dioxide, nitrogen dioxide, sulfur dioxide, etc. So these are some of the acidic oxides. And as you can see, carbon, nitrogen, and sulfur, all of them are nonmetals. So let's see the basic reaction. Sulfur dioxide combines with water to give rise to H2SO3. H2SO3, which is sulfurous acid. Sulfurous acid. So this is an acidic oxide, and as we learned, it should produce an acid. Other example is carbon dioxide can combine with water to give rise to carbonic acid H2CO3. So carbonic acid is again an acid. Carbon dioxide, by being an acidic oxide, will produce acids upon combining with water. Let us look at some general properties of acidic oxides. They are usually existing in a gaseous state. So all the examples that we see here, carbon dioxide, nitrogen dioxide and sulfur dioxide, are all gases. So they are existing in a gaseous state. Second one, they have very high solubilities in water. They have high solubilities in water. In contrast, the basic oxides that we discussed have low solubilities in water. And most important point, they are behaving as acidic oxides, meaning they are acidic in nature. They are acidic in nature. So as a example, let's study the reaction of sulfur dioxide. Now because it's acting as an acid, will combine with a base, let's say calcium hydroxide, and it forms a salt and water. So sulfur dioxide is an acidic oxide, meaning it has an acid property. So it combines with a base, which is calcium hydroxide, to form calcium sulfite, which is a salt. So sulfur dioxide combines with a base to give rise to a salt and water. So these are the general properties of acidic oxides. So the last category of oxides are neutral oxides. Neutral oxides. And as it's there in the name itself, that these oxides are neutral. They are neutral, meaning they are neither acidic nor basic. So it is also possible for an oxide to be neither acidic nor basic, and instead it is just a neutral oxide. Some important examples of neutral oxides include nitrogen monoxide, carbon monoxide, and water. So these are three important examples for neutral oxides: nitric oxide, carbon monoxide, and water. Now because they are neither acidic nor basic, they don't show any reactions with acids or bases. They don't show any reaction with acids or bases, and subsequently cannot form a salt and water. Okay, so these are neutral oxides. A simple way to remember this is to, so no CO water. So no cold water is a simple way to remember the neutral oxides. So this is nitric oxide, CO as in carbon monoxide, and water. To remember the neutral oxides, you can use this small trick. So to summarize, oxides are subdivided into metal and non-metal oxides. Metal oxides are either basic or amphoteric. Non-metal oxides are either acidic or neutral in nature. This is a brief overview of the different types of oxides. If you found this video helpful, do share it with your friends.